Good morning, students. This video is for chapter 5B of standard 9 physics. The topic is relative density, and to know about this relative density, first we should know about the term density. So what is density here? See, if we consider substances, then every substances are made up of tiny particle. So here the closeness of those tiny particles in a substance gives the idea that how dense the substance is. If we take the example, which is denser, water or air, then see, we will compare the closeness of water particle, and it is compared with the closeness of air particle. Then see, in this picture you can see this is a water drop and this is a air packet. Here the particles are closer to one another, more closer to one another, whereas the particles here is not so closer. Okay, then we will say that this water drop is denser. So water is found denser than air. Now the question arises, which has greater mass? If we have those two drops, this one is water drop, this one is air packet, which has greater mass? So to know the answer, see, in the next page we have the measure of density, and here to know the mass of those two, water drop and this air packet, we will consider when equal volume of substances are taken. That means here the water drop and the air packet both are of equal volume. It is taken as those have equal volume. Then we will find that, see, this water drop, the closeness of particle, see, more closeness, particles are more closer to one another, so it has greater mass. And here this air packet is lesser in mass as compared to this water drop. Okay, when those are of equal volume. So if those are of equal volume, so in the place of equal volume, if we take unit volume of the substances, okay, so if we take the unit volume of the substances, then the mass of substance per unit volume is the density of the substance. So this is the definition: the mass of the substance per unit volume is the density of the substance. Now to measure the density, see, we can divide the mass with the volume. So the density is denoted by the letter rho. This is called rho. Okay, so for a substance, this density rho is equal to mass divided by volume. So mass of a given substance is divided with the volume of the substance, and it gives the density of the substance. Now if we take the example, the iron nail, an iron nail is heavier than a matchstick, even those are equal in size. So those are equal in size, that means I want to tell you that those are of equal volume. The nail and the matchstick are of equal volume, but the nail has greater mass and the matchstick has lesser mass. This is only because the iron has greater density as compared to, see, this matchstick is made by wood, so wood is lesser density, wood has lesser density as compared to iron. So that's why the iron nail is heavier. Now see, the note is given here, the density is a scalar quantity. Remember this point. Okay, density is a scalar quantity. So the unit of density, see the next point, units of density. The unit of density, see, what is the formula of density? It is mass divided by volume. So unit of density is equal to unit of mass divided with the unit of volume. So in SI, the unit of mass is kg and the unit of volume is meter cube. So in SI unit, the SI unit of density is kg per meter cube. Okay, and in CGS it becomes gram per centimeter cube. If we set up the relationship in between this SI and CGS unit, so this, see, we have 1 kg per meter cube is equal to 10 to the power minus 3 gram per centimeter cube. So to obtain this value, you can proceed with this line, 1 kg meter cube per meter cube, and in the place of kg you can write 1000 gram, and in the place of this meter you can write 100 centimeter. And see, this one is minus 3, so you can put a by sign here in between kg and meter, and you can take centimeter. So 100 centimeter cube it is. Okay, then try to find out, you will get the same value. Again, if it is 1 gram per centimeter cube, then it is equal to 10 to the power 3 kg per meter cube. So this is the relationship in between the SI unit and CGS unit of density. See, in the next page we have the topic, the subtopic, the effect of temperature on density of a substance. So first, see, if the temperature increases, that means the substance is heating, okay, is heated. So substances expand on heating. This is all this thing we all know about. Okay, the substances expand on heating and thereby their volume increases. When the substance is heated, it expands and that's why its volume increases. But we know this raw density is equal to mass divided by volume. So if this volume, which is actually the denominator, if the volume increases, then we will say the density raw is decreases. So density decreases on increase in volume. So finally the sentence will be like that: the increase in temperature leads to increase in volume. Okay, increase in temperature causes expansion, so it leads to the increase in volume and then the density decreases and vice versa. So vice versa is added here. That means if the temperature, see here, the increase in temperature, if the temperature decreases, then what happened, the volume also decreases and the density then increases. If this volume V decreases with the decrease in temperature, then this density increases. Okay, just the opposite. So that's why vice versa is added here. See, in the next page, effect of temperature on the particle of a substance. So the same thing that we have discussed in the previous page, the same thing we are discussing here, but here in the particle nature, the increase in temperature increases the kinetic energy of the particle, that all of you know. Okay, and then the space among the particle increases. So if the space among the particle increases, this leads to expand the substance. Okay, that means increase the volume of the substance. So the particles are no dense longer, that means no so closer longer, and that is their density decreases. They are no dense longer, that means their closeness is no longer exist here, and they now separate from one another. Okay, that means their space increases, the space between them increases, so we will say that the density decreases. Okay, so density decreases on increase in temperature, and if the temperature decreases, then the density increases, just the opposite. Okay, so see, in this picture you can easily understand, this one is a substance and the closeness of the particle you can see after heating. See, the particle are see, the space become larger here in between the particle. So you can say after heating this increases, after heating, that means increase in temperature, the density, the closeness of the particle is not so longer, not so exist longer. Okay, that means it is no exist longer the closeness, and the particles go away from one another and the volume also increases. So this leads to decrease in density. Now see the next page here, water is an exception, that means it is a special case. The density of water is maximum at 4 degrees Celsius. So why it is special? So let's see, the density of water at 10 degrees Celsius, suppose we are considering 10 degrees Celsius, then it is less. Why it is less? Because of greater volume. Now if it is 10 degree, now it is 5 degree, so the density increases as the volume is decreases. As the temperature decreases, so the volume is, that means whenever from 10 degree to 5 degree the water contracted, that means its volume decreases. Okay, so if its volume decreases, the density decreases. Now at 4 degrees Celsius it got the maximum density, that is the least volume. With the least volume, with the least volume it has the maximum density, the water. Okay, now if further we decrease the temperature, then what we found, actually if further we decrease the temperature, there will be contraction, but this is exception, this is an exceptional case. So here on 3 degree to 10 degree the density again decreases with the increase in volume, that means there is an uneven expansion. Okay, when the temperature decreases, that means the temperature decreases but there is an uneven expansion, unexpected expansion. So this is an exceptional case in water. So we will find that if the volume increases, okay, if the volume increases with the expansion, with the decrease in temperature from 4 degree to 0 degree, then there is a, see, the volume is increases, so that means the density decreases. So for water, the maximum volume, maximum density is at 4 degree Celsius. Okay, now see the topic comes here, the relative density. So what is relative density? Here we found that water is an exceptional case. So the density of water is taken as standard. Okay, at 4 degrees Celsius it has the maximum density. So the density of the densities of the other substances are compared with the density of water at 4 degrees Celsius, which is the standard value. Okay, now the relative density is defined as the ratio of the density, the comparison. Relative density is actually the comparison of the densities with the density of water, that is the standard density. Okay, so the definition will be like that: the ratio of density of a substance to the density of water at 4 degrees Celsius is called the relative density of the substance. So the relative density is equal to, see, this raw S means the density of the substance divided by the density of water at 4 degrees Celsius. So here the line is given, see, density of the substance divided with the density of water at 4 degrees Celsius. So this is a ratio, this is a ratio, and this ratio is called the relative density of the substance. Okay, so see the relative density for same volume. We have another definition of relative density. Suppose we have the same volume, then this relative density is equal to density of the substance divided by density of water at 4 degrees Celsius. So you know that the density means mass divided by volume, but we have the same volume V. We are considering here the same volume V. So this mass of the substance divided with the volume, it is the density, and here also the mass of water divided by the volume of the water. Same volume is taken, so this V cancelled out, and we will get this ms, that is the mass of the substance divided with the mass of the water at 4 degrees Celsius. So this will give the relative density again. So finally, in other word, we can define the relative density. See, the relative density of a substance is also defined as the ratio of the mass of certain volume of a substance to the mass of equal volume of water at 4 degree Celsius. Okay, that means whatever the volume of substance is taken, the same volume of water is also taken at 4 degree Celsius. Then the mass of that substance divide the mass of the water gives the relative density here. So this is the another definition of relative density. Now what will be the unit? So see, the first line, the relative density is a scalar quantity, and it has no any unit because it is a pure ratio of two similar quantities. Two similar quantities, that means two densities. Density of a substance divided by density of water. So there is no any unit for the relative density. It is unitless quantity. Okay, it is just a ratio. Now the density of water at 4 degrees Celsius, which is the standard value, is 1 gram per centimeter cube, which is also equal to, it is in CGS, okay, and in SI it is 10 to the power 3 kg per meter cube. Okay, so density of water at 4 degrees Celsius, that is the standard density, is 1 gram per centimeter cube in CGS, and in SI it is 10 to the power 3 kg per meter cube, that means 1000 kg per meter cube. So the relative density, if we want to find out the relative density, so in CGS the relative density is equal to numerical value of density of the substance without unit. That means what? Suppose we are trying to find out the relative density, then the relative density equal to density of a substance divided by density of water. Here density of water in CGS is 1 gram per centimeter cube, and that for the substance we have the same unit, gram per centimeter cube, so unit are cancelled, so only the ratio is left here. So whatever the numerical value of the density of the substance, that is the actual relative density of that substance, and it is taken without unit. Okay, so it is as it is divided with 1, this value 1, in CGS it is the density of water at 4 degrees Celsius is 1. Okay, so it is divided with 1, we have the same value here. But here in SI unit, the relative density is equal to numerical value of the density is multiplied with 10 to the power minus 3. 10 to the power minus 3 means here you can see it is divided with 1000. Okay, because see, this relative density is equal to density of a substance divided by the density of this water, okay now, which is equal to this 10 to the power 3. So if we have 10 to the power 3 which is divided, then we can multiply with 10 to the power minus 3 like that. Okay, the simple mathematics here. So if we take the example, then we may clear those things, like the density of copper is given 8.9, it is 8.92, but here we have taken 8.9 gram per centimeter cube, okay, in CGS. So if it is in CGS, then simply the relative density of copper is the numerical value, that is 8.9. okay, and the relative density of copper again in SI unit, this 8.9 is multiplied with 1000, so we'll have 8900. So this 8900 is the relative density of copper in SI. So this is it. Thank you, class. Try to solve the numericals and try to answer the questions. Thank you.